Hi, everyone. My name is Renato, and today I would like to talk to you about my experience with managed databases on the cloud, mostly on AWS, as most of the recent talk, but as well on some other environment, actually. I started playing with AWS in 2011. That doesn't make me an expert. That just makes me old. So it's almost 15 years that I'm playing with managed databases one way or the other. Always thinking I'm going to do something different in my life, but that's what I'm mostly doing. On AWS, the very first database was announced in 2009, so quite some time ago. And that's more or less the entire announcement. So things at that time were pretty simple. And I have to say, one of the big benefits to start to play with a managed database, but actually with the cloud in general in 2010, 2011, was that there were so many constraints that was pretty easy. You had many choices that you couldn't do. Once you had done the choice to be on public cloud, it was pretty simple. So back in 2011 was the thing I will remember, I will say, simple. There were so many constraints. And yeah, unfortunately, the bad side was a bit more expensive, but I don't want to go into cost. Just to tell my story was, why did I want to play with managed databases? Because it was definitely not a DBA. I was coming from a software engineer background. I was a Java developer. And I was working for a startup. I had to manage, at that time actually it was a Postgres database that we had on an EC2 instance at the beginning. Yes, can I manage a database? Yeah, more or less. Can I manage a production cluster, replicas, failovers, or whatever? I have no idea. So yeah, when there was the option to jump on the cloud, and to me, the big announcement was not the ability to have a database on the cloud. Was for me the main announcement that really pushed me to be full in on cloud databases was the ability that at that time I consider kind of magic to have a multi-AZ deployment. That by multi-AZ deployment means to have I'm simplifying a lot, but is the idea that yeah, you don't have anymore your primary node and you have to manage your own deployment, your own cluster. But yeah, if something goes wrong with the primary, don't worry, in another data center, something will make it good for you. That was my knowledge at that time. I hope it's a bit better now, and I say before, yeah, things were a bit more expensive, just to give an idea, because we keep saying, yes, the cloud is expensive. Using managed services much more expensive than, at least in pure cost on the cloud, than running your own EC2 and do your own deployment. Then the total cost of ownership may be something different. But yeah, the overall cost of an instance, if you compare for the same size at least, went down. And of course, the performance are better. So all great. The overhead in terms of percentage between virtual machine and managed database, both on AWS, I checked as well, Azure is more or less same, went up. That's quite obvious as well. The cost of the machine went down. The cost of the managed service a bit less. So the overhead is a bit more significant now. I say that was much easier the life of a cloud architect at that time was because I was using RDS, similar service in other cloud provider as well, but basically there was not much choice. When my boss had told me we are going to use AWS, well, I had to use RDS, and there was nothing else I could use. Actually, people think I love to use MySQL because now I'm mostly using MySQL. But actually, at that time, as I said, I was using Postgres. I had to move to MySQL because it was the only engine supported at that time. So yeah, that was pretty easy life. Once you have decided to move, that was it. You had many constraints, no much monitoring, no many, let's call them advanced features, no many choices as well that you have now about which instance, which kind of storage do you want provision IOPS? Do you want, which engine you want to have, different generation, cost optimization? There was not much with that. So the very first thing I've learned in many years is we tend to go to events like Google Cloud events, Cloud Next, or AWS reInvent, and they are there, they announce new features, new things. We are all clapping, super excited for some weird reasons. In reality, that's the day that your deployment might be out of date. Maybe not in a bad way. I'm not saying it's getting worse, but as a cloud architect, I see my job with databases, but not only with databases, to keep optimizing, keep iterating, and try to achieve the best deployment I can give with the resources I have to the company I'm working for. So do I have to keep checking the news and keep it right? Probably not. But if the choices that I made 3 years ago, my managed databases made sense, assuming they made sense at that time, do they still make sense now? Maybe. I made those choices 5 years ago. Do they are still the best choices now, or would I make the same choices today? Probably not. So first lesson is, well, maybe an obvious one, but keep looking at your deployment. Almost all databases might be there for years, many years. Make sure that you're not almost all leaving money on the table, because maybe there's a cheaper way, cheaper option, better way, more resilient one. Go and pick up. In many years, one thing I've learned a lot was actually interacting with support. I'm not saying just premium support, as well community, but as well with simply support cases. I'm showing some now from AWS, but I had the same in Azure. It's like always trying to interact with the support team and validate. One of the challenges I see with databases is, yes, you make an API call through CDK or through command line, through whatever you want to do, but the API call might take milliseconds, but the action behind might take minutes, might take hours, might take days, like almost all on the storage layer. I tend to prefer to validate, almost if it's a prompt for generative AI, with the opening a ticket and just validate what I'm doing and double check there's no other way to do it or a better way. Because sometimes I work by assumption, I work because I used to do it that way. So these are just simple random tickets that I open, that I pick up. They are real tickets. I remove the case number because they are from customers. But as you can see, I'm not just using tickets just to report issues. I mean, of course, a multi-AZ replica broken when scaling up, yeah, is a production problem. I'm dealing with support. Maybe I'm even dealing live. But some other are really simple questions like the roadmap that maybe you don't get, but some comparison, some question like, for example, support for Non-DBA redo log capacity is like things from the community that I have no idea if they are supported or not in the managed version. But let's go to some of those challenges that the pain I had and the solution sometime I found. But so one thing I keep failing is estimate how much storage I need on the cloud. Things are getting better because even on the worst offender like RDS, you now have a kind of very painful way to recover the storage you are allocating. But one of the challenges you have with databases is you put a lot of storage there. You say, okay, I need 4 terabytes, and you start to pay for that 4 terabytes. There might be a good reason why you need them or because you want to pay for it, but how do you forecast how much storage you need and how you claim it back? One of the challenges, see in a second now, is, let's say I want to, you think, okay, I just look at the storage, how it grows, and that's good enough. But the products evolve, and usually you keep the same database. You might change the schema, but you still keep the same storage. You might need to optimize for very different reasons a table. That's MySQL. You might do some alter table that require a copy of your data. If you have tables that are 500 gigabytes, 1 tera or whatever, you need that storage temporary to grow and then come back. And one of the painful way I had, one of the worst downtime I had actually years ago was due to using auto-scaling on the storage. What do I mean by auto-scaling on the storage? Most providers now offer the option, if you are below a certain threshold, is we scale the storage for you. That's usually good. That's what you usually want when you don't do an operation that is temporary. So if I, for example, do an alter table and I have 1.2 terabyte free and I need 1 terabyte, the last thing I want in that database is someone is going to change my storage behind while I'm doing that alter table. Because I know I'm going to recover that after the alter table, after my table has been copied, I'm going to recover my storage. So one lesson is that automation there was pretty good. It's nice to have them. It's nice to keep checking because you don't want to run out of storage, of course, but there are scenarios where you don't want to have it. Sorry. And that brings as well, one of the powerful things that I've always loved about when I say as well, there are multiple ways to do the same thing is, one question I always have is, people ask me in the team as well, how we're going to change, for example, let's say the product has some new changes that you have to apply to the production database, and those changes require a copy of your table because it's not an instant modification to the schema definition. Cool. You can do it with your engine. This case is MySQL. You can do it Postgres or whatever. You can use some third-party tool. That's legitimate as well. There are different ways to achieve the same goal. But as well, you can decide where to do it. And of course, you can play simplest way. Go from the simplest to the hardest one is you can do a change on your main table. You lock the production data. If it takes a couple of seconds, you're happy. If you might have a harder time to come back, or you might do it on a replica node, do it not as a read replica, do the changes, hoping that they're compatible, swap the production database, get some benefit, get some some drawbacks on that. You can use as well some vendor specific. That's the cool part to me of the cloud. There's as well some service that now, like for example, Amazon offer RDS Blue-Green. They're not the only operator having a similar name as well. Reality is just basically a wrapper around create a replica cluster. There's a second cluster, data is synchronized, and there's a swap of the endpoint, nothing magic behind. Cool. Why do you want to do that? And why do I care so much about optimizing the data and the storage behind this? I was so naive that when I started with AWS, and that sentence was there over 10 years ago, and it's still there, is, oh, you never pay for backup or better. We give you some free backup storage because we are nice. You get, if you pay for 1 terabyte of storage, we give you 1 terabyte of backup. So is that good enough? Is that enough to not pay? Trust us, we are the database administrator. Most customers will never pay for backup storage. Unfortunately, that sentence came back to me many times with CTO and other coming and say, so why are you so bad in deploying our environments, or why are we paying a few €1,000 every month of backup storage? And then you have to start to explain that, that's probably true for most use cases if you keep a short amount of backup data. As you can decide the number of days you keep point in time, the ability to do point in time recovery, if your database is pretty heavy on write, the cost of that can go up pretty much. So one thing that I tend to consider always is the contribution of CPU is usually overestimated for database. I'm not saying it doesn't matter, but I'm saying that I tend to have many conversations at the coffee machine discussing, what kind of instance class, what's the best instance class, what's size, how you do vertical scaling, how you do sharding, how many nodes, how many replica nodes are you using? All very cool, but I hear very few people discussing how to optimize the storage, how to minimize the storage you use, how to move cool data outside your primary database if you don't need it there, maybe on a very expensive storage layer. And as well, you can see this is the data from a real production database. Costs are going up because the database is improving. The product is improving, was a successful project. So cost of a reserve instance is going up, is doubling, but you can see as well backups costs are going even more than doubling. And that's just with 30 days of backup. And the contribution of storage and backup is actually significantly higher than the CPU alone. Why? Because this is one of the things you hardly see because you cannot really see it through the API. You can see just through cost explorer, through the billing approach, is that the cost of the charge of backup is going up over time. So if I look the cost of by month of that storage, of that backup, even if the overall backup is not increasing that much, it's always 30 days of backup, and the disk went up of more or less 50%, my overall backup cost went up by 100%. Because, well, binary logs and whatever else are contributing a lot on that. So that's one reason why I suggest, for example, I mentioned those optimization or those optimize of table to try to recompile and reclaim the storage to have, I'm simplifying a bit, but mine smaller size of backup long term. One thing that usually we don't care is which processor is running behind a managed service. And okay, this is a bit of a joke, but that's more or less true. You use a managed service because you don't want to look too much under the hood. So you don't want to know, do I really care if it's a Graviton for ARM processor or an Intel one? In theory, no, because when I use a virtual machine, yes, because I have to deploy my own build. I have to decide which build I'm deploying. I need to make sure that all the packages I'm using work. But if I'm using a database a managed database service, probably I wouldn't care. I just pick up the cheapest one. And that's what I tried to do. And at that time, I had what I thought, that was many years ago, a smart way to vertical scaling my instance using some command line. That was a stupid project we were doing, vertically scaling our instance according to certain metrics. So simplifying a lot, we are monitoring certain metrics using, in this case, was CloudWatch. In Azure was something else. But the idea, we were monitoring the status of the database, we were monitoring the CPU, I think, and the queue depth. And if something was triggering, we were scaling up. If it was below certain threshold, we were scaling down. Pretty simple. Then one day we moved to Graviton, and after a few days, we crashed. You open a ticket to support and you say, we crashed, so that's your fault. And actually it's true, yeah, that was a crash, so that was definitely not my fault. But digging deeper, what I figured out was that I was trying to outsmart too much the managed service. I was trying to make my own logic of how to scale, and that was mainly due to try to optimize the parameter configuration. We keep saying, oh, yeah, that's not ideal, that's the default one. We always find a way to make it better. And that's true, you might find ways to make things better. Oh yeah, why should I use just, 75% of the memory for the buffer pool? I read somewhere in a post that you can push it up to 80%, and you do it and it works. It works until the day it doesn't work. That crash happened because basically I ran out of memory before hitting my CPU target. And the reason was simple, because on the Graviton instance, the ratio between CPU and memory was different. So I'm not saying not try to optimize, but always play with a bit of caution when you play with defaults. They are there for a reason. Try to take them to your advantage, but try always to balance that you might need to change them in the future. So if you can do them that they are not hard-coded value, will be better. So if you can say it's a percentage, for example, of the CPU memory, otherwise, anytime you change the cluster and anytime you change the class or you go to a new instance class, something that maybe you did a few years ago to gain, 1% of your performances or so-called performances might hit back badly. Last mistake I did recently was to go too fast with a project where I wanted to migrate to, the requirement of the project was to move to Aurora. Aurora is a even more managed service than RDS, for the one who don't know it. But if you look at the documentation, you can get that in 30 minutes, I think 20 minutes, 10 to 20 minutes, you learn how to move from RDS to Aurora. And the way you do it, actually, you create a read replica of Aurora a read replica of RDS as Aurora, and you promote that one. Pretty simple, pretty straightforward. Then you get that message. And you get that message because basically, if you know how the entire MySQL world works, but as well the Postgres one is a very similar way, is there's a community edition with some minor version. After a few weeks, few months, the cloud operator bring that community version to the cloud after some testing, some whatever. And after even more time, that internal fork like Aurora that they have is brought to Aurora. And the problem is that you cannot have a primary node, that is ahead of your replica. So what happens is, if you try to keep yourself close to the latest version, latest minor version on, for example, RDS, you are not able to migrate to Aurora for the next more or less 6 months, sometimes 9 months. So sometimes it's better to stay. If you want to have that as a way out, that maybe you have problem with storage and you want to use Aurora, even if maybe it's more expensive for your use case or whatever, but keep in mind that if you go too fast and stay to the latest minor, you might not be able to do it. Same if you do it with your own deployment on EC2 or a virtual machine. But by far, the scenario where I ran out of, I had more problem usually with IOPS. This post, I wrote it almost a decade ago on my blog, and it's still by far, is completely outdated. It makes no sense anymore, but it's still the one that I get most read today. What is running out of IOPS? First of all, I tend, and I see every single project tend to underestimate how many IOPS you use. One of the main reasons is that usually the default basic matrix you have tend to average, or at least the default is the average on period like 1 minute if you don't get enhanced monitoring that you pay for. And then you see, for example, the average of that 1 minute or the average of that 5 minutes. You say, oh, that's 10,000 IOPS. I have 12,000 as a baseline. I'm perfectly fine. Actually, if you dig deeper, probably in a very good percentage of that time, you are hitting already the ceiling. So yeah, it is quite useful, the total IOPS metric, but don't trust that on that one. There are cloud providers tend to evolve. So a few years ago, they announced, for example, GP3 as a better version for default cheaper storage. Is that always better than GP2? It's a bit more configurable, is slightly better because it's more flexible. But there are still some use cases where it makes sense to stay on the older one. But usually the question here is always, there's something new, just double check it. So for example, IO2 Express is incredibly expensive, but it's still much better than IO1 because the same has better performance. So I cannot think of a use case where you can use IO1 unless it's a very old instance that doesn't support the newer storage. And looking at cost optimization, I have tried to save every single penny on every production database to then figure out that database with provision IOPS that is costing in production thousands of dollars per month, got copied in a staging environment that someone using the CDK forgot to switch it off, and getting that ended up costing a copy in staging where the CPU costs were negligible, but the storage cost for that month was a few thousand euros. So keep in mind that when you copy a cluster, you tend to keep the same storage class that you usually don't want to have unless you're doing specific tests internally. Usually, I tend to get wrong how long, I said at the beginning, how long it takes to do a change. So for example, I said before, oh, I can do an alter table on a replica and then promote it. But how long does it take to do it? Create the replica maybe takes a few minutes. After 1 hour, your console says available or whatever language the provider is using. But that storage is coming usually from a backup. They just take the daily backup, take it up, apply the changes from that time of the backup and go on. That storage is usually very cold. So this is an example of even the replica leg on a production database that was pretty heavy, write intensive. You can see that the size of the instance was the same. So here, at this point, the database, here I created my replica, here is fine. I have my replica, is there available? Can I do something with it? Actually, from that moment, you can see that the replica, so the time that the replica is behind because the storage is cold, it keeps going up. So for me, that database is still more or less useless because it's actually going up. It's not even going down. It takes almost 2 days, 2.5 days before going the other way. It took me 3 days to be able to do anything sensible with that database. And anything sensible meant that in that scenario, it took me 3 days just to be able to do stop the replica, do the alter table, create more replica leg. Took 1 week to do the entire operation. So that one is usually one thing I get it wrong. And another side effect of doing, for example, blue-green, now there's a new option that allows you to pre-warm the blue-green, is that you do the blue-green, you are happy because it's just one button, everything goes great, you are super happy. Unfortunately, when you go, the disk is cold, your queue depth explodes. For the one from you, queue depth is basically your database is performing pretty badly. The user experience of your online user is going to be horrible. I skipped the experiments because unfortunately I have no time for that. But the final question, are you really not a DBA? Reality is I'm not a DBA, but the definition of DBA has changed in the last few years. This is a very old screenshot from Amazon, but the idea is, now a DBA on the cloud is more an application DBA than really a platform one. So lesson learned, change to allocated storage might take hours. We saw it at the beginning, plan accordingly. You might play with a managed service. So it's all wrapped up. You don't know too much, but logs usually, performance schema, parameters are all there. You just have to look for them. Try to avoid changing the full settings for short-term gains, unless you do it for a specific reason, specific product. Create as well some alarm to roll it back, whatever, because you might need to scale the database later, and when you do it, they might fight back. Validate your finding with the support team. They have access to your database. Doesn't mean to your data, but one of the challenges when you use managed database, you have no access to the file system. They have access. So if you give them the right question, the right challenge, you might get some feedback. Warm up your database replica. I said before, cost optimization is vital, but just don't focus on the CPU instance, but think about storage and backup. And yeah, I didn't have time to check benchmark, but yeah, that's another story. Anyway, the only message I will give is use managed services, try to resist changes, and almost all try to understand what is running under the hood. With that one, thank you so much.